And get going. I don't think we're waiting on anything. Um, my name is Chris Sanders. Thank y'all for coming out. We've got a lot to talk about today, not a lot of time to do it, so I'm not going to spend a lot of time gabbing about myself. I think the most important thing on this slide is the fact that I'm an analyst, so I spend most of my time trying to catch bad guys or thinking of better ways to catch bad guys, so I think that's certainly relevant to the audience in this room, or at least I hope it is. Show of hands, does anybody else identify kind of as an analyst? Do you spend time trying to catch bad guys? Quite a few of you, okay, that's good. Beyond that, I think the most relevant thing on this slide is the fact that I'm involved in some PhD research. I've been in computing for a while now, and in security for a while now, but I decided I wanted to go back and get some further education, but I didn't want to study computer science or some of the typical stuff. I was really a lot more interested in the human component of it. Computers, to me, can get a little boring. If you get the right people in the room, you can figure out everything that's going on for the most part. But with humans, generally the most or the least understood thing that exists in the world, right? So there's a lot more opportunity for phenomena there and additional research, and that was of interest to me. So that said, I went back and I started work on a PhD in cognitive psychology and applying that to the investigation process. And that's a little bit of what I'm going to talk about today, are some of the things I've discovered, how I frame some things, and some of the research I've already conducted, along with the methods I've used to do that and some of the results. So I think that speaks to kind of the core of this conference, is the whole science of everything. Now I want to frame things through this concept of cognitive crisis, and I want to do that through the idea of medicine. Right, so I want you to think in the medical field, and right now the medical field is pretty successful. There are a lot of problems with medicine in general. Most of those are related to financial side and of course insurance and things like that. But medical research is in a good place, and it's probably in a better place than it's ever been. But it didn't used to always be that way, right? And I want you to think about medicine as it existed 150 years ago, and it was really in this state of cognitive crisis. And I think you can identify a cognitive crisis with three particular points. One of those is the demand for expertise greatly outweighs supply. So 150 years ago, not every town had a doctor. You might have to travel for a couple days to get to one of those places. There's a good chance you could die along the way. You could die of dysentery on the Oregon Trail on the way to your doctor, so to speak. And even the towns that had doctors, that doctor was also your dentist, and he was your vet, and he also fixed your furnace on occasion, right? So not the best scenario. Beyond that, most of the information that existed cannot be trusted or validated. There wasn't really a formal system for educating or training doctors. There wasn't a formal system for documenting knowledge and sharing that. That's why people used to, when they had a stomach ulcer, would drink milk to make it better. And we found out not that long ago, actually, that actually complicates things and hurts things and makes it worse. Right? So we have this system now where that's a lot better. And number three is a symptom of a cognitive crisis is there's an inability to mobilize and tackle big systemic issues. That's when we had plagues and a third of Europe getting wiped out by various diseases and no ability to curtail that too effectively, whereas now we're getting a lot better than that. So I frame that in terms of security operations, and I can talk about why I think we're also in this state of cognitive crisis, but I think it's best said by those who are outside of our field. And I ran across a study that was conducted by some researchers at Kansas State University. They're actually anthropologists, and they did an ethnographic research study. Ethnography, if you don't know, is basically the study of culture within a group. So God help these poor anthropologists. They took them and put them in a security operations center in a working organization and had them spend time with security folks learning what they do and how they do it. Pretty neat. The study's out there. I've got it linked. You can go look at it, and I recommend you do. It's a pretty good read. But I want to highlight a couple quotes that I think are relevant. Number one is that an analyst's job is highly dynamic and requires dealing with constantly evolving threats. Doing the job is more art than science. Well, that's awful convenient for the name of this conference. Ad hoc on-the-job training for new analysts is the norm, right? And if you've ever been in a security operations center, that probably makes sense to you. You walk in on your first day, you don't have a lot of experience. They tell you, okay, our training program is go sit over here with Cletus. Cletus is our best analyst, and watch him do what he does, and you can learn from him, and that's your training program, right? We've all been there. So that's on one side. The next quote is that the profession of security is so nascent that the how-tos have not been fully realized, even by the people who have the knowledge. The process required to connect the dots is unclear even to the analyst. Wait a minute, though. On one hand, you're saying, go sit with Cletus because he really knows what he's doing. But on the other hand, you're saying, well, he doesn't actually know what he's doing. He can do the job, but he's not really good at articulating why that is. right? And I think that is pretty descriptive of security in general, not just on the defensive side, but really all around. There's this general lack of understanding of how we do what we do, how we connect the dots. I often feel like I'm pretty good at catching bad guys, giving an alert and running it to ground, but not very good at telling people exactly how I did that. And I think a lot of us can probably relate to that. I'm seeing a lot of nodding heads, so I think that means so. So if you look back at these symptoms of cognitive crisis, these certainly apply to security as well, right? I think that's why a lot of us are here. Demand for expertise. If you're trying to hire skilled security professionals right now, then you're really feeling this. You can't find them. And when you can find them, you got to pay them an arm and a leg. Skilled security expertise has now been priced to the point where small and medium-sized businesses, the ones who really need it, can't afford it. And that's a shame, because when you consider that most businesses are small businesses, and they're often connected to bigger businesses, that causes problems for everyone and hurts the economy in some pretty real and measurable ways. Most information cannot be trusted or validated in security because all the best information exists on blogs, right? And that's a good thing in some ways, but in a lot of ways it's hurting us because there's no barrier to entry there. There's no peer review in a lot of cases. Even sometimes when information is good and valuable, nobody's going through years after and pruning that. So when you're doing your searches, you're looking for how to solve a problem or how to implement something, you're finding 5-year-old information that's no longer valid and is going to get you into trouble. So that's unfortunate. And of course, if you want to talk about the inability to mobilize and tackle big systemic issues, look no further than ransomware, right? That's kind of the topic du jour right now. There's enough money flowing through ransomware infrastructure and operators right now that it probably exceeds the GDP of a few small countries. And that's going to probably continue to get worse before it gets better. You can look at the recent MongoDB and various database providers there, the ransom going on there. So it's going to keep getting worse. And quite honestly, we've done a very poor job as an industry trying to tackle that or even make a dent in it. So I do believe we're in this cognitive crisis related to these 3 points. Now, if we want to get out of the cognitive crisis, and the reason I mentioned medicine earlier is because they did it. They did it very successfully. That's when we have medical school now. That's when we have residency now. We have this whole mentor-apprentice thing that goes on there and is very well structured. And medicine is a lot better off for it. I'm not saying the answers for medicine are the same answers for us, but learning how they got out of that and the process they use, I think, is very important. Now, I break it down into 3 points here. I think the way medicine generally did this is understanding the processes used to draw conclusions. Once you do that, developing repeatable methods and techniques, speaking to the introduction to the conference earlier, and then building and advocating training that teaches practitioners how to think and how to approach those things. So for the rest of this talk, I'm going to focus on number 1, understanding the processes used to draw conclusions, because I think that's where you start, and I think that's where we are. We're certainly not fully at 3. Of course, these things aren't sequential either, right? They're all happening at the same time. So hopefully if you're responsible for training analysts, or if you are an analyst and you're feeding that training material back up to your organization, you can get some value out of this or even apply it some way to your organization. So that said, I want to talk about some research I've done that I think is applicable given that cognitive crisis. And research generally begins with a good question. And the question I had is, going back to our friend Cletus, who's the expert, if we've got Cletus on one side and Billy Bob on the other side, one's an expert, what's a novice, what is the thing that separates them? And you might say, well, Chris, that's easy, it's experience. But what does that mean? What does it mean to gain experience? When you gain experience, how do you quantify that? What are the things you're gathering? It would be very easy to say, okay, it's knowing how to use tools, and that's probably a small part of it, but I would argue that's the smallest part of it. As most of us know, once you learn how to investigate an IDS alert, it doesn't ultimately matter the tool so much. You spend a little time learning. You spend a little time learning a SIM or what have you. But once you understand the core concepts, you kind of get it and move on. So what are those core concepts? So that's the question I asked. And I did a study. I did kind of a call for investigators, both novice and expert. And I said, okay, come to me and I'm going to interview you. And I want you to tell me about a case you worked. Some cases, it was multiple cases for some people, but at least tell me about one case you worked. What was the input? What were the steps you took? And what was the conclusion you got to? Right? And the conclusion is this bad? Is it not bad? How bad was it? What should I do about it? So these encompassed a lot of things. They encompass network security monitoring type investigations, incident response, a little bit of malware analysis too, because that's still an investigation. And I took about 30 of these case studies, recorded it, did some interviews with people, and then I played those back and I did a key phrase mapping exercise. So that's basically where you identify things that map to certain constructs that you're looking to measure, right? And I did that based upon something called dual process theory. And without going too far into this, dual process theory essentially states that the human brain it thinks in two different streams, or two interconnected but different streams. One of those is intuition, which is your fast automatic thinking. So when I tell you to multiply or to add 10 plus 10, you can do that immediately without thinking about it for the most part, and that's intuitive thinking. Now, if I ask you to multiply 37 times 42, that's going to require a little bit more, right? Most of us probably couldn't even do that. Or well, I don't want to judge you people. I know I couldn't do it. But if I tell you to do something that requires a little bit more deliberate thought, more attentive thought, that's reflective thinking. You're actually having to apply specific focus to that type of thinking. And there are a couple keywords and a couple different processes associated with each of those things. And you'll see I have intuition there on the left, reflection on the right, and in the middle I have metacognition. Has anybody heard the term metacognition before? Blank stares. So metacognition is basically a fancy way to say thinking about thinking. It's regulating your thoughts, understanding your thought process, all that. There's been a lot of scientific studies out there that prove in fields like medicine that if you are more metacognitively aware, if you're more aware of how you think, you're going to be a higher performer. So it stands to reason it might be effective for us too. So metacognition kind of sits not necessarily between intuition and reflection as it's represented right here, but as a concept underlying both of those. So I did these interviews and mapped the things people said to these different structures to kind of get a sense of what the differences between these novices and experts were. So do y'all want to see the results of that? So I've got them all laid out on the screen here, nice and pretty. And there's a lot that can be dissected from here. And I have a feeling I'll spend a long time, next couple of years, probably dissecting a lot of the things. But I do want to highlight a couple of the findings that I think are the most important. You see we have the three categories. We have intuition on the left, reflection on the right, metacognition in the middle. And then novices are highlighted in blue, experts in red. And these are the average number of responses in each category. Now, on the left, I found it interesting if we look at incubation. So incubation is basically to say that I've encountered a new piece of information, and I don't necessarily know what I'm going to do with it. So I'm just going to acknowledge that it's something new and interesting, but I'm going to kind of put it to the side, let that incubate for a while, right? So we see a much greater rate of incubation for novices than experts, more than double, right? And when you look at research like this and look at bar graphs, you also have to ask sometimes, does it pass the sniff test? And this does pass the sniff test, right? Because if you think about it, if I'm not good at this, if I've never done analysis or investigations before, I'm going to run into a lot of things that look interesting that I just don't know what to do with, so I'm going to kind of incubate those. In fact, as a novice, most of those may turn out to be nothing because everything's going to look weird if you don't know what normal looks like. But we see a much greater rate of incubation there. Now, on the flip side, if we go to reflection here, I think the interesting thing is rule-based reasoning. We see we have a much greater rate of rule-based reasoning for experts and novices. And rule-based reasoning basically says, if you want to think kind of like a programmer here, it's kind of an if-then statement. If I see this thing, then it means this other thing. And I can use that output to make other decisions or feed it into another if-then statement, which is pretty neat. And we see a much greater rate of that for experts. Now, that also kind of passes the sniff test too, right? If I'm an expert and I've been doing this for a while, then I probably have a much greater library of these if-then statements, of these rules or these heuristics that allow me to make decisions, right? So that's pretty cool. And I would also say, and it doesn't show here, but there's to some degree a relationship between incubation and rule-based reasoning, because given an expert and a novice with the same input, if you can either, if you don't know what it is and don't have one of those rules, you incubate it. If you do know what it is and you have a rule or heuristic to process that, then you have a sense of, okay, here's what I can do with that, and you're not incubating it, you're applying rule-based reasoning, right? So that makes sense. There's kind of a relationship there, which I think is really neat. Now, the other thing I think is interesting here is if we look at this metacognition section, is that in general, experts tend to rely on metacognition a lot more. At least they have an ability to be metacognitively aware much, much more. Which shouldn't be, I guess, a big surprise, right? If you're better at this, that means you're probably doing things like evaluation, goal setting, and making plans because you have a better sense of what you're looking at, what are the inputs, what are the outputs, what are the different rules I'm applying. And speaking earlier to the study I mentioned where with medical professionals, those who are more metacognitively aware perform better, it stands as a reason here that, of course, experts are going to perform better, so they're more metacognitively aware. So it kind of goes both ways. Now, from a training perspective, I think this is neat because, especially in terms of metacognition, because you can actually train people to become more metacognitively aware, right? It's getting away from teaching about tools and getting more towards teaching people how to think and what is metacognition, what does that mean, how do you set specific goals, what does the investigation process look like holistically, instead of kind of microscopically focus on specific things, right? Like it's important to know what packet capture data is, but it's a lot more important to know when you should use it and how to use it, right? And I think that gets lost a lot of ways. But that's all related to metacognition and how we can make people more metacognitively aware. So again, there's a whole lot that can be dissected from this slide. We don't have a lot of time, so I'm just going to hit those few things. Now, the next question I asked was really related to the flow of the investigation and analyzing and understanding that. So I want to understand basically the processes people use to get from A to Z. So we use the phrase connect the dots a lot, right? What does it mean when I say connect the dots? I go a little deeper there. Now, the problem with this is that investigating the investigation, so to speak, is pretty hard. Now, investigations are at the center of everything we do, whether you're a malware analyst or you work in a SOC, you're an incident responder, you're doing some form of investigation where you have that input, you pull and review a bunch of evidence, and you come to a conclusion, right? But it's also very hard to study because it's a lot less about technology and more about humans, right? Humans are complex, and for that matter, when we all have different tool sets, it introduces a lot of variables, and variables in some way are kind of the enemy of good science, because if you have too many variables, then you can't control those variables, and it creates an ability where you can't measure anything effectively. And that's exactly what I'm trying to do, is measure things effectively. So how do we do that? And that was a challenge I fought with for a really long time. And eventually I realized that the best answer I could come up with was to follow the data. If you've been in multiple SOCs, you may have used multiple IDSs, you may have used multiple SIMs, you may have built your own SIM, you may have bought a SIM, you may have PCAP, you may have bro data, you may have flow data, you may have all of those things. It's very different. But regardless of what tool set you have, most of the data, although it can be represented in different ways, most of us are used to at least some common representations of data. Flow records, when they're presented in raw text outside of a tool, all look the same. Packet captures, when they're presented as raw text outside of a tool, mostly all look the same. DNS records, so on and so forth. All the different types of evidence we use to investigate when badness has occurred. So I took that information and I built basically a simulator. In the simulator, you see it on the screen here. At the top, we have an IDS alert, and then we have a part that you can navigate through where it says, okay, here are the different data sources you have available, and you have to ask it questions to get the answers you want. We have this cheat thing we can do in investigations where you can just say, show me all the data, but if you're on a network of any size, we know that doesn't really work practically. So you have to ask it the right question to get the data you want, and of course, as you're doing this, we're logging and recording what you're doing. So we come up with these complex investigation scenarios and say, work through this, and we review the results. Results often look something like this. We do some reporting here where we're looking at the time. This was just an example, so most of these are taking a lot longer than 3 minutes, usually in the 15 minute to an hour range for most of these. And then there's a skill level, and we do some comparisons. But here you can see a user started at a place, they looked at a live process list for a host, looked at the host file system for a certain file, looked at open source intelligence, so on and so forth. So this allows me, as the guy who's trying to understand the investigative process, to present a scenario to a large group of people and then systematically tweak certain variables within that scenario and measure the differences that are happening, which if you're a nerd like me, that's a pretty darn exciting thing. So basically for the rest of this presentation, I'm just going to go through some of the results of the things we found. I've got a lot of things, and there are a lot of things in the slide. I'm not going to be able to get through them, but the slides will be available. So even the things I'm not going to get through, you can look at on your own. So the first question I ask is, what does an analyst look at first? Because it seems to the reason that matters, right? So an analyst, if there's something they're looking at first, that's the thing they're probably saying is going to be the fastest way to come up with a result and determine if something bad actually happened. So what I observed was this. Packet capture data was looked at first above anything else, right? And these were, I don't have it shown here, these were data sets where there were a lot of different things available. A lot of host data, a lot of network data, probably over a dozen different types of data. PCAP was first, and you see there are only actually 3 things that were looked at first. And that's to be expected. The flow of the investigation was such that it made sense to look at one of these 3 things probably first. So nothing groundbreaking here, right? This tells us that analysts kind of prefer a higher context data source, even if other data sets are available, and even if the lower context data sources can lead to a resolution. I can tell you that with this investigation scenario, you didn't actually have to look at packet capture data to solve it. It was not necessary at all, but still people chose to start there first. Makes sense, it's a higher context data source. So that's not that's not going to wow you, that's not an amazing finding. But I did ask this question, which I thought was pretty neat. Did the first move affect analysis speed, right? As investigators, we want to be able to be accurate and we want to be able to be fast, right? In most of our organizations, security is overhead, so the faster we can do it, the better. And the results on this one kind of surprised me. This is the average time to close for these analysts. This is in minutes. Those who started with packet capture were much slower at coming to a resolution about what was happening, right? And that was pretty interesting. So while there's richer context there, it doesn't necessarily get you to the answer faster. And that, if you think about it, it makes a little bit of sense. There's a lot of data in packet capture, and probably the data you need to actually answer the question you're looking for is a very small amount of data. But you have to wade through a lot of crap to get there, right? And so that's kind of unfortunate that that's the case. So I said, okay, well, PCAP is this highly unorganized, really high context piece of data. So can we take that, organize it a better way, present basically the same data, and see speed increases? So if you're not familiar with Bro, it's a network tool that basically takes network data, separates it out into different logical constructs. It basically takes a PCAP, gives you a lot of the same context, but organizes it a lot better. So I said, okay, let's do the same experiment. Different group of analysts replace the PCAP data, remove it completely, and put Bro data in its place. So this was with PCAP data, 72% chose it first. With Bro data, only 46%, so a lot fewer folks. Some of these people were maybe not as familiar with Bro or just not as comfortable with it. Some of the ones who were just didn't want to start there, right? So a fewer number of people chose that. But then we measured the time to close, and this was the previous stat where 16 minutes for PCAP. Does anyone take a guess what happened when I put Bro data in? Did it go up or down? Okay, so a couple different answers. So the time to close actually went down quite a bit. It normalized it. So at that point, Bro was exactly equal to flow data, very close to OSINT data. So this isn't too revolutionary, right? But better organization of higher context data sources matters. And this gives us a way to kind of measure that, which is pretty neat. So, and I don't say this to advertise for Bro. I love Bro, I use Bro, but really this applies to anything, right? So anytime you have a data source, you know, we also think, okay, give me all the data. I want all the raw data. And you probably want to have access to the raw data, but the way you present things and the order in which you present things matters. And this was a case where we're presenting essentially the same data, but we're organizing it a little bit better for the analysts so they can find the answers they need better. So if you're in the business of building tools, take note, this part matters, right? The next question I asked is what data sources were viewed most and least frequently? And this pretty straightforward. You might expect PCAP was first, right? It was the first thing looked at. Nearly everyone looked at PCAP data. Nearly everyone looked at open source intelligence data. A lot of people looked at flow data. Also tracked revisits here. So what data sources had the most revisits from people? So that means they looked at it once, came back and looked at it again. Overwhelmingly, that was PCAP. Again, higher context data source with a lot to see. Now, I think the interesting finding here was that if you look, all these on the left here are network data sources. All these on the right are host data sources. This scenario could have been completely resolved only looking at the host, only looking at the host data. Network data was not necessary to resolve the investigation, right? So, pretty neat. I'll say there's probably a little bias in here that my background is network security monitoring, more network than host. I think anecdotally, there were a few more people in this study who are probably the same way. They're more network than host focused, so that probably slanted it a little bit. But I don't think it's fully explained. I think the answer is that most people are more familiar with the network side than the host side, which makes sense to some degree because the network side is a lot more predictable. Protocols, for the most part, HTTP is going to look like HTTP, DNS is going to look like DNS. Hosts change with every new operating system, every different type of architecture, so that is a little more variable, so people aren't as akin to look at that. The last thing we're going to look at here are how many steps were taken to make a disposition judgment. You'll see here we have a distribution of those. So basically this is how many questions the analyst asked to get from start to conclusion. And you see most people fell in kind of this normal distribution looking pattern. In the middle here, we had a few people who took a lot of steps, a few people who took a few steps. I'll say anecdotally, I don't have it presented on the screen here, most of the people who were experts were on the lower end, right? So they're asking fewer questions and focusing on specific data. Most of the people who were novices were on this right end. So these three people specifically were all people who were lesser experienced, and they were spending more time in doing these things. Of course, as you might imagine, average time to close kind of ascends like this, where people are looking at more data, are taking a lot more time to resolve the investigation. So a lot of people, I think, especially when you're new into investigations, would say, you know, I want all the data possible. More data is better. More data, more better. In this case, I would say that's not the case. I would say the most efficient analysts are the ones who look at the least amount of data necessary to solve what's going on. Path of least resistance kind of goes back to this sense of questions. Asking the right question is kind of the crux of the investigation process, and I think that's kind of what we're revealing here. So like I said, I have a couple other things. We're out of time, so I'll put those, I'll leave those in the slide deck, and by all means, if you have any questions afterwards, feel free to email me. I think do we have a few minutes for questions? Yeah, we have a few minutes for questions now, so if you have questions, I'd love to take them.
Talk a bit about where you got your people for the study.
Yeah, so the question was where did I get people for the study? A couple of them I got from Manient. We have obviously a lot of analysts. A couple of those. I try to get it more people I didn't know than the ones I did, just to try not to bias things. Either way, I still randomized all the results when I could. Beyond that, I put a call out on my blog and said if you want to participate in this, by all means do it. I also teach a class focused on this and the process of investigations, and some of my students I got to participate as well.
What kind of alert was used in the study for sources and decisions? Was it an IDS alert or was it a bunch of different things?
So that was all IDS alert. IDS alert generally for these presents the simplest scenario because it tells you basically here's what happened, here's a signature so you know what happened, and here's some things you can pivot off of. So they were all IDS alerts for that case.
Do you think using the IDS alert tilted people towards looking at network sources?
So they were all IDS alerts. They were not all network IDS alerts. That's probably worth clarifying. Some of them were host-based IDS alerts. One of them was like a tripwire style thing where like a system file had changed something had changed in it or something like that. So it was not all necessarily network-based. But for the ones that were network-based, yeah, I could definitely see that being the case. Yeah, absolutely. Any other questions?
Just talk real quick about the imagination part of the difference between the novice and expert. There was a really pronounced difference being used with imagination.
There is. I'm not quite prepared to talk about that yet because I haven't quite unpacked those findings as far as imagination yet. So I don't want to speak to that without being knowledgeable enough about it yet.
So one other question was about the earlier step, meta-cognition versus some of the other thought processes for experts. It seemed that rule-based following or having an algorithmic way of approaching things was very highly important with experts, but so was an imaginative approach or coming with exceptions. It seems kind of contradictory. Is that something that just mapped to different people, or was that something that was consistent across the entire population?
It was pretty consistent, and I don't quite have an answer for that one yet. It's not one of the ones I've unpacked yet. Like I said, I think that particular slide is one, and the data associated with it is one I'm going to be spending probably it's going to be a big part of the dissertation, so it's probably going to be a couple of years before I've fully understood all that. And it's ongoing as well, right? So I had about a little over 30 folks in that. I'd like to have closer to about 100 by the time I'm done, so I present it with that caveat. Yeah, so the question was, do I have any insight into whether people feel as though they do better with more or less data? And overwhelmingly, people will generally say, give me as much data as possible, is what I've gathered. And I didn't show as much of this. Most all these findings were paired with surveys before the fact, where I asked people, how many steps do you think you normally take to do an investigation, things like that. And it really revealed that most people don't understand their own process as well. So most people, like the thing where I asked people, there was a study I'll briefly mention, where I asked people, given no additional information, if I gave you an investigation, there's a friendly IP address and a hostile IP address, which one do you investigate first? It was like 60-40, people said hostile. In practice, I conducted the same thing. Over 90% investigated the hostile IP address first. Right, so it kind of shows that people don't necessarily think so much about this, and even if they do, they maybe don't think correctly about what they do when they're under the gun. Sir.
Did you look at anyone who was actually crafting forward security rules? I've written a lot of certified rules for communities. I've written a lot of processes for that. Is that accounted for in the sort of what you present to people, or are you just saying just work the event, don't worry about it?
So you're asking if I present an IDS signature, do I expect them to validate the signature? For the most part, no, I don't provide any directions either way. I think they know, at least in all the experiments I've conducted thus far, there's no data set associated with it that says, we'll show them the signature, but there's no, we show them the alert. Matter of fact, let me just be easier if I show. So you notice on this one, we actually show the signature, and we actually have a section here for alert packet. So there is an ability for them, if you're knowledgeable at signature writing, and many of these people definitely are, to go in and say, okay, well, first I want to make sure this is a proper signature fire, absolutely. And there were a lot of people who did that. In this specific scenario, it was not one of the ones where I measured opening move, so I didn't see that in that part of it. But I would imagine, say, if it was, a lot of people would do that, because a lot of us are trained first to validate that the signature wasn't a misfire. So absolutely. So different components of this presentation were from different labs. Anybody else? What's next? Well, you know, this, like I said, this slide in particular, there's a lot to this, and you know, there are definitions for what lots of these things mean, but what the operational definition in terms of what that means for us and how you practically apply it, because none of this matters if you can't practically apply it, right? So I'm doing a lot of digging on this, and we'll continue to do it for a long time. Like I said, I now teach a training course on this. I've taught it internally at Mandiant for a little while for free. It's a paid thing now to fund some of my research, and that allows me to gather more research. So when you join that training, you actively become a participant in that research because you're going through these investigation labs, a lot of them. And I'm getting feedback on that. So it's really to continue to ask interesting questions about the investigative process and continue to find useful findings that are useful from both the training perspective and the perspective of tool developers, because I think that's the other side of this, is not just me as an individual analyst or me as a SOC manager training my people, but if I'm building tools, I should be building tools for the analyst. A lot of companies want to focus on the detection, but every interaction the user of that software has with you is after the detection's occurred, right? So that process has to be nurtured and facilitated. So that's the focus. Okay, well, that said, if you want to contact me, if you have any interest in any of this stuff, if you'd like to participate in a study, I'm always looking for folks to talk with. Reach out. Thank y'all for the time.